Okay. Thank you. One thing that I want to bring up before we get started, we got the real boss of the museum here, which happens to be Captain Hodgson's wife. Donna's up here in the audience. She's one that keeps the thing going out there, contrary to what anybody else might think. So we're glad that she's here with Jim. A little background on Jim. He will be the first pilot in North Texas to fly the Dreamliner for United Airlines. And right now he's flying the 777, and he'll start flying the Dreamliner in September when United receives its first aircraft. Jim graduated from the University of Illinois with a BS in Industrial Engineering in 1971. And upon graduation, he was commissioned as second lieutenant in the U.S. Marine Corps and became a naval aviator in 1972. Jim flew the OV-10 Bronco, TA-4J Skyhawk, RF-4 Phantom II aircraft, and earned a master's degree in business management during his career with the Marine Corps. Jim left the Marines in 1978 and joined Continental Airlines, which that's who he's still flying with. As you know, United and Continental got together, but he's still a Continental Airlines pilot. And he started out his career as a flight engineer on a 727, and he moved up to the 737. And in 2008, he transferred to Boeing 777 as a captain of international flights for Continental Airlines. He's currently captain flying the Boeing 777 to China, India, the Middle East, and Europe. In addition to his aviation career, he is the founder of the OV-10 Bronco Association and presently holds the position of executive director for the Veterans Memorial Airpark in Fort Worth. And as Bob says, he's one of our directors on the B-36 Museum. He's married to his wife, Donna, in 1974, and they have one son, Rob, who lives in Austin. With that, please welcome Jim, and I'm sure you're about to hear a good program on a great airplane. Thank you.
Good evening. Before we get started, how many of you are pilots? How many of you flew commercial? 7.2? 7.0? Any of those? Okay, I kind of want to have an idea of who's here tonight. At any rate, I received my type rating on the 787 on May 1st, just another couple of weeks ago. So one of my friends referred to that as my new call sign now is Captain Mayday. So we'll see how that goes. We're going to do something a little bit different here tonight, since this is a little different. We're not talking about old things tonight. We're talking about something that's brand new. We normally wait and have questions at the end, but if you'd all go ahead and test this, that mic in front of you, you have to press the button and hold it down until the light turns green. Keep it down while you're talking. So if everybody would just press the green button, or press the button, get the green light, and just say hello.
Hello.
Okay, because we're at any point in time here this evening that you have a question, just press the button and ask. Okay, we're not gonna wait, because I'm going to cover a lot of information. Our transition training for the 787 is going to be 4 or 5 weeks for new pilots who haven't flown the 777. My transition was called the differences training, and it was 2 weeks. And it was a very, very full 2 weeks. As you may have heard from somebody who wrote about it, they didn't feed us with one fire hose, they fed us with about 9 of them. So at any rate, there's a ton of information about this airplane. And I refer to it as alien technology in a lot of cases, because anybody fly Boeings in here? You ever heard the term, if it ain't Boeing, I ain't going? Okay. Well, there's another one. A Boeing is a Boeing is a Boeing. This is not a Boeing airplane. Boeing may have built it, but I'm not certain where all the technology came from on this one. So we're going to go ahead and get started. You might notice here that there's a trophy here in the corner. And the reason for that is just last month, I believe it was last month, the 787 and Boeing were awarded the Collier Trophy for 2011. So that's the most recent airplane to have received the Collier Trophy, which goes back to the 20s. Okay, we're going to start with the electrical system. Okay, I said that because I wanted to see everybody's eyes glaze over. We're not going to do that at all. Anybody who's been involved with airplanes, you start talking about electrical systems and they just all kind of go to sleep. So we're not going to do that. What we are going to do is start with a little video, if I can... oops, that isn't... Okay, we're going to have to do that from here. This is the first flight of the Boeing 787, December 15th, 2009. And there'll be a prize for anybody who can tell me where this music is from afterwards. Okay, we're going to leave it there. It goes on for a little while and they taxi and it gets really boring, so we're not going to do that. Okay, here's what we are going to talk about this evening, though, and why the 787 is so different. This one talks specifically about the 787-8. The Dash 8 is the version of the airplane that's presently being produced and coming out. The Dash 9 version, and you may see some references to that, is a little bit longer version of the airplane. It's got about a 20-foot plug in it, makes it bigger. So we're going to talk about some of the things that make it really different. Advanced wing design, the breakthrough passenger cabin, the overhead crew rest, the enhanced flight deck, innovative systems technologies, composites, large cargo capacity, and advanced engineers or engines in nacelles. And we've got some other things throughout here too. So the first thing a lot of people want to know is, well, gee, it's a really big airplane. Well, it's kind of a chubby boy because it's right up here. It's being compared to a 777-300, which is the stretch version. But you'll notice that it's smaller than a 777, although it's got the same fuselage side. And although this is the 300 version of the 777, the 200 version and the wings on the 78 are essentially the same. They're within about 3 feet of each other, being the same wingspan. And this is a 767, so it's a lot bigger than a 767. You're also going to see that there are a lot of comparisons made between the 787 and Airbus. And this is one between the 787 and the Airbus 380. They'll also see comparisons to the 330 and the 340. This is nowhere near the same size as a 380. But one of the things that they have found, and we'll talk about a little bit here this evening, is that this airplane, if you flew them side by side with a 747, 777, and a 380, would be able to fly as twice the efficiency of those other airplanes. So this airplane, even though it's a medium-sized airplane, is considered ultra-long range, 7,500 to 8,500 miles. And a lot of the things that's being talked about with this airplane is taking it to markets where you can't put 500 or 600 people in it like you can with the 380. The seating capacity is up to 290. So in some respects, United is talking about this airplane being used in kind of a role of the southwest of the Pacific. High frequency, low volume flights all over the Pacific long haul. Okay. This is one of the things that the people talk about on this airplane all the time. You'll notice the airplane in level flight, 1G, the wings are slightly above or actually this is kind of on the ground. The landing gear's not down, but this is on the ground, and the wing tips are almost up at the top of the fuselage. In flight, that's what the wings do. Max load on the wings. Okay, so we go from there to there, normal flight, max load on the wings. And that's before they break off. Okay, so the airplane with max load on the airplane can still fly like that. That's maximum load. But that's one of the things they talk about on the wing, these big flexible wings. Another one of the things that the technologies that's been built into this airplane is what's referred to as, yes?
Have they fatigue tested one to break at that 26 feet of flex?
Well, if you go on the internet, you can look up wing loading or 787 wing flexes, and you can see the tests where they break the wing. And it's in excess of that 26 feet. Otherwise, I'm not going to fly it and let it get up to 26 feet. Vertical gust suppression on this airplane. I'm going to speed through a lot of these slides. I'm not intending to read these to you. But this is a representation here of what the vertical gust suppression does for the airplane. This is the normal. The blue would be a normal ride in light to moderate turbulence. And with the vertical gust suppression, it smooths the ride out. That's really cool. And the way it does that is that the wing has an active variable camber and cruise. Spoilers move. The flaperons move. We don't have any control over this in the cockpit, but we can sit there and watch the hydraulic system work on the flight controls, and they're sitting out there moving all the time. It's like a bird's wing. The camber of the wing changes, the flaperons change, the spoilers will come out a little bit, and all kinds of different things to smooth out the ride for everybody who's on board. These are some of the other breakthroughs in passenger cabin. This is one of the things everybody talks about so much, or been talked about so much, is the window. Here's the 787, here's the 777 window. And anybody who's ridden on an airplane has that stiff neck after they've been trying to look out the window for a while, right? Well, with the 787, it's a lot bigger. In fact, they refer to it as everybody on the airplane has a window seat, because no matter what seat you're in, you can see outside. Now, here's the other thing that they talk about, the tricky part, is this little button right down here. You'll see it's gray on the bottom and white on the top. There are no shades on this airplane. Those are the shades right there. You press the button and electronically, the window changes its tint from clear to dark. I know, this is the gee whiz stuff, you know. It's, the other part, here's one of those comparisons. This is a cross-section of the cabin of a 350, and that's the airplane that's most often compared to the 780 is the Airbus 350. The red is the cross-section of the Airbus 350. The 787 is bigger. It's virtually 12 foot across interior. It's about 16 feet on the outside. but Boeing refers to it as the double bubble. Since the airplane is built of so much composites, they can do a lot of different things with the fuselage on it. One of them is giving more capacity inside, and I'll show you what that's going to do for you in just a little bit. But you can see this guy's got a really bad seat on the 350 over here. This is part of the interior of the airplane. You'll notice it looks very spacious. One of the things, because of that double bubble and because of the composites, they can do a lot of different things with different levels within the airplane architecturally. And so this gives you a feeling of being more open. I'm going to show you a couple of other things here too, that they do a lot of things with lighting on the airplane. This is the same cabin. Essentially it's the same cabin, but it's different lighting techniques. There are no light bulbs in this airplane. It's all LEDs. And so United refers to it as mood lighting. We've got about 9 different mood lighting settings. For instance, the blue is going to be nighttime. So if you've ever been on airplanes, long-haul airplanes at night, and it's dark and you stumble over people's feet and things like that, this airplane you're going to be able to see as you walk through, but the lights will be blue, so it'll be compatible to sleep. In the morning, it's going to turn to yellow. At noon, it's going to be white. But they've got all these different mood lighting settings with the lighting that they can do inside the airplane. I've got a little video here that I'll show you that you'll see some of that. But this is one of the things, and being able to vary the lighting within the airplane also makes you feel like you're in a bigger atmosphere. Some of the other breakthrough cabin things is that since it's a composite structure, and we'll talk about that a little bit later. Since it's a composite structure, we maintain the cabin pressurization on this airplane at 6,000 feet. Normal airplanes, it's 8,500 to 9,200 feet in the cabin. So this is a lot less pressure on you, so that you are going to be more rested while you're in there. We can also humidify the cabin, which is something you can't do in a normal airplane because, why? Because if you put water in there, it corrodes the airplane. This isn't going to corrode. So we can humidify the cabin on this airplane. So it supposedly is going to be a lot more comfortable. You're not going to dehydrate while you fly long distances, and with the lighting and all of those things, plus the cabin pressurization system and the air conditioning is supposed to be a lot more comfortable and a lot more refreshed on long-haul flights. We talked about the overhead crew compartment, crew rest. Here's the cockpit. The pilot's crew rest is above first class. See, there's a little doorway here and a little ladder, and you go up, and there's a couple little crew rest areas up there. The flight attendant's crew rest is up in the back end of the airplane, up overhead. If you noticed in that cabin cross section, there's a lot of headroom in there. So this is where the crew compartments are. And I've got a video that actually shows you a little bit of that. This is a basic configuration on some of the airplanes. I think this one is total of 219. You can get a configuration up to a total of 290, but this is 219. This is the enhanced flight deck. No comments? This is the first cockpit I flew in as a commercial pilot. This is a 727. You're all supposed to laugh. You're supposed to notice this stuff. Okay. This is a 727, and I can tell you I was almost as excited going into the 787 cockpit a few weeks ago as I was the first time I went into this. But this is what I started with 34 years ago, and this is what we're doing today. Okay, this is the cockpit of the 787. Some of the things that you're going to immediately notice in here are the big flat panels. We've got 5 big flat panels across the front, 2 for myself, 2 for the co-pilot, 1 down here. We've got electronic flight bags here on the side of the airplane. We also have heads-up display. These are not deployed. These are in the stored location. But all of these panels, we've got a couple more down here. I think we've got a total of like 17 in the cockpit. Most of them, especially the 5 big ones, we can move the displays all over in there. They're all virtual. So we can put all kinds of different things on the different panels at different points and times in flight. We can put up synoptics of the different systems of the airplane. We can put all kinds of different presentations of our flight path. For instance, this one, it's a little bit hard to see, and I think I've got a better picture later, but what you're seeing is a plan view of what you're flying over, the way you normally would, like on a radar screen, where you're over the top and looking at all the terrain around it. We also have a vertical situation display, which is kind of a side view of the path of the airplane. So it's very, very helpful when we're flying in areas where there may be terrain or we're seeing weather ahead of us, because we've got a brand new radar that's called a multi-scan radar. And it sits out there and looks out in front of us and does all kinds of different scanning and computations, and it only shows us what's going to affect our route of flight. So we don't see a lot of stuff that may not have any effect on our route of flight or at the altitude we're at. So it's really pretty cool. So this is the cockpit. This is what it looks like when you first walk into it. Pilots get interested in funny things sometimes. We walked in with my classmates. I was in the second class at United to go through, and so we refer to ourselves as second-class pilots. But one of the guys walks in and he puts his finger up here right away. He flips up this little cover and puts his finger on there, and he says, "This is the thing I've been waiting to do. I've been waiting to do the whole time." There's the control for the seat is right underneath there that makes it go backwards and forwards. On the 777, it's over here on the side, and you got to bend over, and you got to kind of reach around the seat and everything. So it's funny what pilots like. So at any rate, anybody notice anything that's missing up here in the top, in the overhead? I mean, that looks kind of small, right? Who's flown commercial airliners before? How many circuit breakers did you have in the cockpit? Too many, right? There are no circuit breakers on this airplane. Not one. And if there are, none of them are in the cockpit. So it's, the next thing that we need to do in this is we're going to have the dog who's in the cockpit and bite you when you try to touch something that you're not supposed to. And this is about the circuit breakers. This is one of the synoptics. There are no circuit breakers in the airplane. This is one of the panels, one of the things that we can pull up and look at. And it will show us all the different circuit breakers in the airplane, and whether they're an electronic circuit breaker or whether they're a thermal circuit breaker, whether they've got collars on them, which mean you can't use them. And instead of pilots, one of the great adventures in the cockpit is finding the circuit breaker that's out. You went in there and it's like an Easter egg hunt, trying to figure out which circuit breaker is out. It pops out, it's supposed to be white, or they've got collars on them and that kind of thing. You can never find them. Well, this one is almost pilot-proof because we can check by flight, we can check by nomenclature, we can check by state, we can do searches, we can do all kinds of things to find the circuit breaker, the virtual circuit breaker that's out on the airplane. And never again will a mechanic, do we have any mechanics here? Mechanics do this embarrassing thing to pilots all the time. You call in, you work through a problem, you can't get something to work, you call them up finally, you tell the mechanics, "Come on out, we can't get something to work." He walks out, reaches up over your shoulder, and punches in a circuit breaker and goes, "Okay, does it work now?" And they do that to you all the time. They've been doing it to me for 34 years. They will never do it to me in this airplane. I am going to show you a little bit about systems. We're not going to dwell on it, but I want you to be able to see what we can see in the cockpit and what makes this so much different. This is the electrical system. The electrical system on this airplane is basically 4 giant generators that are on the engines. We've got 2 on each engine. Each one of them develops 235 volts AC. These are huge, big generators. We start the engines together at one time, and it's an electrical start because we have no pneumatics on the airplane. So it takes almost 2 minutes to start the airplane. So you bring the fuel control levers up, and the airplanes just sit out there and spin, but it's these great big generators that are going round and round. They go through transformers and rectifiers, and we get it down to 115. We also have 28 volt on it, and the power is distributed between the front and the aft of the airplane. We've got 2 big, what are referred to as electrical and electronics bays on the airplane. One's up front, one's in the back. 2 big giant batteries, one in front, one in back. And we also have something that's very different here, which is we have distributed control on the airplane. We have remote power distribution units. There's like 20 of them, and they're all over the airplane. That's what all these little yellow things are. We don't know what they do. We don't necessarily know what they control because we don't have to, but they're all over the airplane. This is what makes the electrical system so different. The APU has 2 of these same generators on it, and we also have what's called a RAT, or ram air turbine, right here. In the event that the engines quit working or the generators all go out and the APU can't start, this little thing drops down and spins like a windmill out there and will provide electrical and hydraulic power to us. One of the other things with the electrical system that's interesting is this little box that shows up when we're doing different things electronically. This is one of the synoptics we can pull up on the airplane. This one is the electrical system, and it's just kind of a cartoonish view of this same system. Here's the three, the generators off of the engines, the generator controls and all that. But this is the interesting. It's called load shed. The airplane does two things. It does what's referred to as load shedding and load inhibiting. And what that means is that based on its own algorithms in the computer, it knows when it's starting up that it doesn't have enough electrical power to power some things. So it will either not let the system start up, which is load inhibiting, or it will shed the load. In this particular case, what we're looking at here is essentially external power in an APU. So this is prior to start or just at the beginning of start. And so the load has shed the cabin loads, and we don't know particularly what that is. That could be the galleys, it could be the in-flight entertainment systems, it could be the power to the seats. The airplane will decide what loads it's going to shed at the particular point in time that it's at. So there's comm, nav, exterior lights, whatever. So at any rate, this is one of the synoptics we can pull up so we can see what the airplane's doing. We have the ability to pull up synoptics on virtually everything. Here's all of our different buttons that we can push. And these are all virtual buttons to bring up different systems. Here's the fuel system, which relates to how the fuel system on the airplane is. This is a hydraulic system. We have three main hydraulic systems. Anybody ever fly the 727? Okay, do you remember the thing about how to remember the hydraulics? That's saying, breaking up the aft air stairs, right? Okay. Which means nothing to most everybody, but to pilots, you always had to remember what you had on different systems if they started to fail. If you lost the left one or the right one or the center one, and so we always had these little acronyms, and on the 727 it was breaking up the aft air stairs, which was a code for which systems you still had. Okay, finally somebody at Boeing got this right, and this is why I consider this alien technology. We have three hydraulic systems. The left system controls everything on the left side of the airplane. The one on the right side controls everything on the right side of the airplane. The one in the middle helps out these other two, plus does the landing gear and the nose wheel steering. Ta-da! And it's only taken them how many years to get to that, so at any rate. This is another one. We can look at the air conditioning and see what's going on throughout the airplane and the air conditioning and also down in the cargo compartments. And this is what's referred to as ICAS on the engine instruments. This is all the engine instruments information. So these are just different things that we can pull up on these different screens. This screen right here shows you a horizontal display of what the airplane is doing if you were looking down over the top of it. And this is the vertical situation display that I mentioned. So you're getting not only the plan view of where you're going, but you're getting a side view also. And so this is taken in the simulator down in Houston. Looks pretty real out there, doesn't it? We were just getting ready to do what's referred to as a 300 RVR takeoff in the airplane. 300 RVR means that our visibility is not any longer than the end of a football field. It's 300 feet. And right now, commercial airliners can't do 300 RVR takeoffs. 500 is about the best you can do, except in the 7-8. We can do 300 RVR because we have this heads-up display. And I'll show you a little bit about that, but we can go out there and roll down the runway without being able to see much of anything and take off. We've always been able to come in and land that way, or not always, but have for the last 10 or 12 years. But these different displays, we can move them all around. This display shows us our tape for speed and altitude and courses. This is a compass display down here. Another horizontal display, vertical display. This is engines. Somebody actually finally put the landing gear handle in the middle of the cockpit. Okay, it's always been on one side or the other, so somebody was reaching across to get at it. This is our ICAS information. We can do our ACARs and ICAS. This is all kind of the technical part of putting in our flight plans and being able to run our checklists off of these. But we can put them on any screens we want. That's the nice thing about this. We can move it all over the cockpit and put them on any screens we want. We can lay out for start. Actually, they've told us that there are 46 different combinations. And I think I went through all of those the night of my check ride. I'm not quite sure. This is what the heads-up display looks like. This is what's considered the full display. This is a graphic of it, but here on the left-hand side we have a vertical tape that shows us our airspeed. Right now it's showing us that we're at 145 knots, up to 200, down to about 100. Our ground speed's 141. Here's a compass indication. We're in heading select, heading 093, which is essentially east. This is our altitude indications. We're at just over 800 feet here. This shows our glide slope, where we are in relation to a glide slope. This shows where we are in relation to our vertical course. And up here is more of our flight control information. So this is what's on our heads-up display. This is what we're looking through and looking at most of the time. This is what it looks like when you're actually looking through the window, and this is what's referred to as the decluttered mode. There's a little button on the yoke, and I think you'll notice on this one we've got all of this altitude and airspeed information. Well, when you get in close, you don't need that anymore. I've still got airspeed, I've still got my altitude, but what it's done now is it's laid out the runway for me, and it's taken a lot of that information out because now I'm below 500 feet, and I just want to be concerned about putting the airplane on the ground. But this is pretty cool. This is the kind of stuff that we all kind of thought was going to be difficult to get used to, and it was going to take us a while. And it took about a half an hour to get used to this thing. If you've been in the military, you flew in the military, a lot of people have flown with heads-up displays in the military. That's different. You're trying to kill things. Here we're trying to save things and all get on the ground okay. But it's still the same kind of thing, and it took no time at all to get used to this. Got to the point where we were not looking at the other guidance instruments because everything was right here in front of us. Okay, we got another little video here. We've talked about the interior of the airplane, and this video is going to. I had a hard time finding one that kind of showed you the whole interior. It runs a couple of minutes, and this is very amateur. It's just a guy walking through the airplane with a camera, but it'll give you a good idea of the things we've been talking about in the interior. That's the big windows. He's going to take you up in that crew compartment now, and you'll never see this on a real airplane because you won't be allowed to. This is the pilot's crew rest area. There's an escape hatch that comes down out of there if you get locked in. Right down on the top of somebody sitting in first class. That'll be a real exciting afternoon. You can stand up there, you can walk around. It's made for 4 pilots. There's enough room almost to lay down on the floor. Now you're going to get the light show. And that's all you need about that. Just to give you a little idea what the cabin is like and the lights and everything else. Here's some of the technology things that make the airplane so special. This is the innovative systems technology, as we're going to refer to it, the breakthrough stuff. The breakthrough technologies reduce fuel burn per seat by 20%. Actually, it can even be a little bit more than that, but a good portion of it is systems, part of its materials, the aerodynamics of the airplane, and the engines. Engines are a big factor, but the materials are too. So here's a little bit more. Over normal airplanes, 20% more fuel efficient than compatible. Here's one of the big issues. 30% less maintenance costs over the life of the airplane because of the composites. One of the things that they talked about, for instance, you've all been around airplanes a little bit. If you ding the side of a metal airplane, depending on how big the ding is, it can ground the airplane for a long time. Somebody runs a belt loader into the airplane or something like that. Even a scratch of a couple of 3 inches can down the airplane. With this airplane, it's essentially plastic. So they've got a little patch kit. And they take this little circular template, put it over the ding in the side of the airplane, rough up the side, essentially put Bondo on it, put a Band-Aid over it, essentially, and then run a hairdryer over the top of it. You're good to go. Anywhere between an hour and 2 hours maximum to repair 80% of the dings to an airplane that would normally ground them, and you're on your way. 20% reduction in CO2 emissions and a 60% noise reduction. I'm going to show you a graph of that. It's pretty amazing. Did anybody go out to DFW? Yes.
Are the wing spars composite?
Pardon?
Are the wing spars
The
composite?
spars themselves, no. And I'll show you some of that here in a minute. Did anybody go out to DFW and see the airplane come in over the weekend? The thing that surprised me the most was how quiet it was. I wasn't out there for when it left. I was there when it came in, and it's really, really quiet. This is the efficiency for part of the medium haul. This is where this airplane lives. You can see it's out here with the 777s. It's actually above the 777s and the 74s. The only thing that can fly further than the 78 in its basic configurations is a 777-200 long range, and there's not a lot of those around. Otherwise, everything else, it's out there at the 8,000, 8,500 mile range with a seating capacity of around 300. So this is that area where the airlines want to use it, and virtually every major airline now has options and orders on for this airplane. I think the orders now are up over about 900 airplanes. Everybody wants this thing because they can take them to a low frequency or low load type of a market and take people a long way and still make money with it. I'm not going to read through these things, but here's some of the 787 advanced systems. I'll note a few. We talked a little bit about the flight controls and the variable camber, advanced technologies. We've got a thing called the Common Core System, and I'm going to show you something about that. This is the computer stuff, the Common Core System. Otherwise, we've got integrated flight controls, integrated this, integrated that, and E-enabled airplane. Originally, there were some concerns about the airplane and how electronic it was and the architecture of the network and whether people could be able to hack into it or not, but we think they've fixed that. A lot of the rest of this is the advanced aerodynamics of the airplane. They did an awful lot of 3D work with the airplane, put it through wind tunnel testings, virtual, and everything else, so that we've got laminar flow nacelles and the variable camber trailing edge on the wings, and tightly integrated this and advanced that. But it's you notice the shape of the airplane is different. You've seen the flexes on the wings. There's some other things. Here's something we'll spend a little bit of time on, the advanced energy management of the system. We talked about the hybrid electrical system, and it is hybrid, 230 volts AC. I think the airplane produces, I think the number is 1.3 megawatts of power. That's enough to power small cities. And that's what the airplane does all by itself. Whoops. And that, of course, we use the basic 115 and then also the DC. They've eliminated pneumatic bleed systems. On every airplane you've ever ridden on, up till now, the way they've heated and cooled you, the way they've run things on the airplane was to take bleed air off of the engine as the engine was running and pump it through air cycle machines and things like that to produce oxygen for the cabin and to keep you comfortable and pressurize the cabin with that. There is no bleed system on this airplane. Small bleed system to heat the core of the engine and under icing conditions to heat the cowl lip on the engine to keep ice off of it. Otherwise, there's no bleed air for the anti-ice on the wings. There's no bleed air for the air conditioning system. None. So it's eliminated all of that ducting and all of that weight on that. That was one of the big things. I mean, this was the hardest concept for me to get my mind wrapped around, is that there's no pneumatics on the airplane. It's not there. You're taking oxygen from outside. You're heating it. One of the biggest problems the airplane has, since it's electric, is cooling itself. And so we've got electrical cooling units. I think we've got these big electrical cooling units that cool down these big, huge, giant electric motors that are in there. We have electric wing and protection. There's 4 blankets, essentially, that 2 on either side of the airplane that just heat up the leading edge of the airplane, or a portion of the leading edge of the airplane. Let's see, adjustable electronic air conditioning, talk about that a little bit. Adjustable speed motors, APU with 2 220-volt kVA starter generators. Again, having an APU on an airplane that does not produce air is a different concept, too. It just produces electricity, and it will be able to power the airplane up to its service ceiling of 43,100 feet. It will automatically kick on if it loses the other generators, three of the 4 generators. If it loses the hydraulic system, the rad automatically pops out and produces a hydraulic power. It's really it really thinks ahead on a lot of these things. This is what they refer to as the Common Core system, and this is more related to computer stuff than anything. But there are nodes throughout the airplane, and it distributes the computer power throughout the airplane, and that's essentially what it is. It's this remote devices that are all throughout the airplane. We don't even know what a lot of these are. Go ahead.
Does it have Wi-Fi for all the passengers?
You know, it's supposed to. We're not going to. Right now, our airplanes at United don't have it incorporated. They probably will by the time we get the airplane, because everybody's putting it on. I heard on the radio today that if you fly Virgin America, you're going to be able to use your cell phones in flight. What a joy that'll be for your fellow passenger next to you. But at any rate, yes, a lot of the airplanes do have Wi-Fi available, and this one certainly has the capabilities, but we don't know about it on ours yet. I'm assuming that it probably will. A little aside to that, Wi-Fi on airplanes. When we fly international and we fly on the overwater routes, the North Atlantic and over the Pacific, oftentimes, especially going to Europe, we're flying along with other airplanes and we're within 1,000 feet of them. You know, just kind of tracking along in these tracks. It's like super highways and that kind of thing going along. And you'll always find people who find, like with U.S. Airways flights and stuff, who have Wi-Fi, that you always try to get close to them if you can, because then you can steal their Wi-Fi signals. Okay, now we're going to talk about the composites a little bit. And this is a thing that they talk a lot about. 50% of this airplane is composites. 50%. 80% of this airplane is lightweight materials. So you can take a look. We've got steel. Steel's yellow. Look hard. Where do you see steel? Steel holds the engine on the airplane. And it's probably interior on the wing spars. But I actually... engine pylons, yeah, that's about all you see. Steel is only 10% of this entire airplane. Titanium, very strong, very lightweight. Where do you see that? On the back end of the engines and on the wingtips, rudders. Aluminum, not even a lot of aluminum on the airplane. Leading edges, and that's about it. Otherwise, it's all composites. This little green thing in the front is the largest, when they tell us, it's the largest produced crystal dome, because it's not even a regular radome. It's some kind of a hybrid crystal dome on there for the multi-scan radar. This is what makes this airplane special, and what they tell us makes it so economical. It's also why we call this the 7 late 7 sometimes, because this airplane was due to be out on the market in 2008. If you will notice here, all of these pieces of this airplane are coming from all over the world. There's U.S. partners, Australian partners, Asian partners, European partners. Forward fuselage from Wichita. Cargo access door from someplace in Sweden. Part of the wing body, fairings from Winnipeg. Engines from Ohio and the U.K. Tulsa's producing part of it. Gloucester, UK. Nagoya, Japan. Charleston, South Carolina. Foggia, Italy. Fredericksburg, Washington, Melbourne, Australia, Toulouse, France, Seoul, Korea. It's an international airplane. It's being built all over the world. This is a little bit of what some of the partners are doing. These are the North American partners. Spirit's doing some of the cockpit and fuselage work. Charleston is doing what are referred to as barrels for the cabin, and they're also doing part of the tail section. Here's the heavy industries in Japan are producing the wing. That's wing right there. This is more of the wing right here. Heavy industries in Japan and Korea. More structural parts. This is from Europe. Aliana Aeronautica. So the airplane is being produced all over the world. Larger cargo capacity. This gives a little diagram of what the airplane can carry. This shows for the Dash 8, it can carry 16 of those containers up front and 12 of them in back. The big issue that Boeing makes out of this airplane is it has, for the same size as the Airbus 350, it has 45% more capacity in the cargo compartment. The cargo compartment also has 2 areas where you can put live animals, which is a big deal if you're taking your animals with you. I would never recommend that, but we used to have a switch on the 727. Anybody remember what we called that switch on the 72? We called it the dead dog switch. You had to depressurize there were times when you had to depressurize it, and you knew that if there was somebody's dog downstairs, when you turned the switch, their dogs were going to die. That's not the case here. But this airplane can carry lots of pallets. It can carry pallets and containers, and it also has bulk area. The big issue is it's got the same cross section as this 777. This one carries 26 of these pallets. The 777-200 carries 32. So it can carry a lot more cargo, and essentially it has revenue generating capability below the floor that other airplanes don't. Advanced engines in nacelles. Not going to get into this too much, but here's what we talk about. The wing, the leading edge device is the anti-ice. In a 777, it's bleed air. 787, it's electric. Air conditioning, 777, bleed air. 787, electric. Cabin pressure, bleed air, electric. Engine start, bleed air, electric. Engine generators. For the 777, it's 220 kVA generators. For the 787, it's 4 250 kVA generators. That's a lot of power, a lot of electrical power. The airplane comes with 2 basic engines. One is the GE, which is the one that United will have. And notice the blades on this. I'm not certain if I've got a better picture of that, but notice the composite twists and turns on the engine fan blades. It also comes with Rolls-Royces. Here's part of what's keeping the noise down, is these little scallops on the back. You know, all airplanes have these little characteristics that everybody looks at and notices, and that's the way they can tell the differences, kind of like cars. This will be one of them for a while at any rate, as the 787 has that scallop on the back of the engines in addition to the wing. If you notice when you look at a plan view of the airplane, the wing tips almost come back to the empennage, to where the tail starts. Almost come back to that. So they really sweep back a long way. Plus the flex. These are just more of the things of the engine technology. It's the scallops on the back. No engine bleed systems in the architecture. That helps. The low noise nacelles and chevrons, engine types are interchangeable, yada, yada. Anybody want to read some more of that? Okay. This is what I think is impressive. This is Heathrow Airport, just for the sake of showing an airport. And these are the noise signatures of the 787, the 76, the Airbus 330, the Airbus 340. This is the noise signature of the 787. Right there. 60% less area affected than the A330 and the A340. It's really quiet on the outside. Really quiet. And that's what's going to make it important for the places that it goes. It's going to be able to go places that are in high noise sensitive areas, and it's not going to be restricted by curfews and some of the other things. Plus the ability to come in and out of places, land in 0-0 conditions and take off when nothing else is moving on the airport. So the airplane's going to be highly efficient at being able to move cargo and people around. Okay. This is about an 8-minute film, and this is going to show you all about those different partners that I mentioned, and it's going to take you through the process of building the airplane. And I think you will like this.
The 787 will be built differently than any other airplane that Boeing has ever built. Instead of being made from metal, it's made from carbon composites. And what we're seeing here are the heads of the machines that lay down the tape. Carbon tape it comes in rolls like duct tape. It is rolled along a surface and laid flat. The carbon fiber is infused with epoxy resin. And this black material on top of this slab is what's being laid. And when they're making a fuselage, they spin a barrel. This is called a mandrel. It's a cylindrical mold. And they lay the tape. There's the tape head machine again, laying the tape in layers one after the other as the mandrel spins and the fuselage takes shape. You can see it turning as the head works its way along. And so they make the layers of the tape, and when they've got the shape ready, they put it in a giant oven. That's what this is. It's called an autoclave. They've had to build some of the biggest autoclaves in the world for the 787 project. The one in Wichita, for example, is 30 feet down, they're 70 feet long. They take it out and it's baked hard. The material is black when it's not painted. So you'll see airplanes no longer having the shiny metal unpainted surface, joining two of the fuselage parts together. And there we have the beginning of the Dreamliner. For the first time ever, the wings of a Boeing airplane will be made overseas. Boeing developed in its research center here down the margin of the way the method for making the wings. This is the composite skin being fitted to the ribs of the airplane. And this picture is in Nagoya, Japan. This is the Japanese now having fully developed the technology. The big blue cylindrical thing there, that's the autoclave. In this plant built just for the 87, the wings slide along on these automated trolleys and slide into the oven. But the very first piece, the first 787 that had to be built was the center wing box. It's actually part of the fuselage that holds the wings. It's built by Fuji in Japan. And here we see the first center wing box of Dreamliner #1. This part had to be redesigned later because we did some testing. Strong enough. The Dreamliner will be built differently than any other Boeing airplane in that it's being assembled around the world. The huge pieces that are delivered to the final assembly plant in Emirates come in this, the Dreamliner. It has a swing tail that opens out, and a large cargo loader takes out the pieces that have come from Italy, from Japan, from South Carolina, from Kansas. Boeing calls this the DBL, the darn big loader. Here we see coming out the back the rear fuselage built by Pyeatt in Charleston, South Carolina. And sliding up behind it in the white covering is Section 41. That's the front fuselage, including the cockpit where the pilot sits, built by Spirit Air Systems in Wichita, Kansas. Two of them were loaded on the darn big loader and taken into the factory for assembly. The idea is that eventually these pieces will come fully stuffed in all their systems. They didn't arrive that way originally when Dreamliner 1 was put together. They were empty shells. Now these are the wings arriving from Japan. Again, the swing tail of the Dreamlifter is open and the wings have come out. You'll see they're missing the edges, the leading edges and the trailing edges. And here's the largest section of all that comes in a single piece. That's coming from Charleston also, built by Global Aeronautica in Charleston, South Carolina, is the entire 85-foot long mid-fuselage section. And this, from Italy, is the horizontal stabilizer, the horizontal tail. There are the wings, sort of the Japanese wings, just fitting through the doors of the enormous doors of the airplane assembly plant. They fit. Now once inside, they'll move these pieces together for final assembly. There's the center fuselage section. You can see the place where the fairing will go around where the wing joins the fuselage. This is the very back of the 787 assembly bay. You can see it's section 41 from Kansas, joined to the midsection that's come from Charleston. The black composite material has a coating over it to protect it, so that it will have this greenish color. If the aft fuselage is being joined, made by bolt. When Dreamliner 1 was first joined, they had a gap between the other sections. Here are the wings coming on. Look at how slender those wings are. And now here's one of the most difficult pieces to join. It's the horizontal tail, and behind it you can see the APU, the auxiliary power unit, that little cone at the back that's named Korea. And in this piece of tooling, they will finally join everything together. At the very back, you'll see a tower, kind of blue and gold tower, that's it there, called the mother of all tooling towers in Boeing's jargon. And they use that to pull up the vertical fin. You can just see the vertical fin of Dreamliner 1 being attached. That's the only piece of the airplane made by Boeing. It's made in Frederickson near Tacoma. The engines. In this case, Rolls-Royce engines, sent from England to go on the first Dreamliner. The landing gear, made by a French company, Pyeatt. And with the big joins made, the plane is ready to move forward to the next position to start getting all the systems installed and connected. That's Dreamliner 1, just before the rollout 2 years ago. We didn't know then that most of the systems hadn't been installed. Dreamliner 1 rolls out of the factory in 2007 to go across the 526 freeway on a bridge into the Pyeatt hangar to be painted.
Okay, that gives you a little bit of an idea how the airplane was put together. Fairly impressive. Big airplane. Any questions so far?
Did they tape those sections together?
Pardon?
Those sections of composite?
They're essentially glued. They're essentially glued together.
Duct tape?
Well, I don't know. They said it was like duct tape on the outside. One of the things I wanted to mention was with the engines. The engines produce 70,000 pounds of thrust per side. That's 140,000 pounds of thrust. The 777 that I fly is 90,000 pounds per side, or 180,000 pounds of thrust. But they're taking a lot of that off of the airplane with the bleed. So the 787 has more power coming out of 70,000 pounds of thrust than the other one does. This airplane, yes?
What happened to winglets?
The winglets, if you take a look, and you can kind of see it here, all they've done with the winglets is they've taken them from this. Does everybody know what the winglets are? You know, there's those little things, the stubs that stick up. And the purpose of those is that they reduce the wingtip vortices. They reduce the drag on the wing by about 2 or 3%, which, when you're flying a lot, adds up. In fact, the winglets all paid for themselves in a matter of a few months when they put them on. If you'll notice on this airplane, and they put them on first on the 767-400, they took the winglets essentially from where they are here, they laid them flat and twisted them back. And so so that you get the same effect by taking that wingtip and rotating it back a little bit. A couple of the other things that I didn't mention earlier. What's the pressure per square inch on a Boeing airplane's hydraulic system? Anybody? 3,000 psi. Okay. Anybody who's ever flown a Boeing knows that. 3,000 psi. 5,000 psi on this airplane. The tubing is smaller, so they could reduce the weight, and so they went up to a 5,000 psi system on the airplane.
That's what the V-22 is, up to 5,000 psi.
The V-22
the
is
rotor.
the B-2. Oh, the V-22, yes. The B-2 is a 6,000 psi system, and so this may be one of the few times when the Boeing military people walked across the hall and talked to the Boeing commercial people, because they don't usually do that. But yes, it's a 5,000 psi system. The engines on this airplane, we can do what's referred to as a single engine go-around. So we practice that a lot. Lose an engine, come in for the approach, lose the engine, and miss the approach and take off and ground. We can do a single engine go-around in this airplane at reduced thrust at the max gross landing weight of the airplane, which is 380,000 pounds. So reduced thrust on one engine's completely dead, the other one is at reduced thrust, and we can do a single engine go-around with that airplane at max gross landing weight. It's just amazing. Yes, Angela?
Type rating?
Type rating?
Separate type rating?
Separate type rating. It's Boeing considers them a common type rating between the 777 and the 78. I can tell you that they're not going to, that United is not going to allow 777 pilots and the 787 pilots to swap back and forth.
But
They
the
are
FAA
similar
has
because
separate.
they are similar in that they fly. They are very similar in the way they fly. It's all software. I mean, they could make this thing fly like Dumbo the elephant if they wanted to, because it's all software. So it is designed to fly like the 777, but the systems are far, far different, and there's a lot of differences in the cockpit and the systems that you have available to you. One of the things I didn't mention, it's called Integrated Approach Navigation, IAN, and this is another one of those concepts that's new to this airplane. What that means is, again, this is kind of a pilot thing, but we are normally used to flying ILS approaches, which means you've got an instrument landing system that the airplane hooks on to a course into an airport, and it has a fixed glide slope, usually of a 3% descent rate, and the airplane can follow that glide slope down on an instrument landing system and go ahead and land. And the airplanes can now do that to 0-0 capabilities. We call them a Cat 3 Land 3 capability. Hands off all the way to the ground. They're still not smart enough to turn off the runway, so we have to do that part. But this airplane has what's referred to as integrated approach navigation, which means that if the airplane can come up with a course to a runway and a glide slope based on instruments on the ground or the database in the airplane or GPS or any number of other things, that all the approaches are flown the same way. How many of you folks have ever flown what's referred to as a back course approach, right? And you can never remember, do I put the front course in or the back course in? All the different approaches right now are flown differently. And so the concept here is you don't care what kind of navigational systems you have available to you to get to the airport. You fly them all the same. It's going to reduce errors in the cockpit. It's going to make the workload for the pilot simpler. All you do is when you're cleared for the approach is you press the approach button and the airplane flies into the airport. It's
Required navigate RNP?
Oh yeah, that's RNP. That's it's called RNAV RNP. It's area navigation with required navigation procedures and those kinds of things. So our RNP, for those of you who know what that is down to 0.13. Yes. You mean as far as length? What are our runway length limitations? We can work out of runways as short as 4,900 feet, depending on altitude, temperature, and some of that kind of stuff. But 4,900 feet is about all we need. Yes?
Enhanced visual systems?
Well, that's the enhanced visual systems. We've got those all over the cockpit. the HUD display is essentially the enhanced visual systems that we use. We use the HUD for everything.
So it'll go through fog?
Oh yeah, absolutely.
Okay.
Absolutely. And the nice thing about the HUD too, I mentioned the multi-scan radar. When we look at the radar display, there's all these little rules that you had for radar before. You had to run it up 3 degrees up or 5 degrees down, or if you were at so many miles out, you did it 20 degrees. I'll get to you in just a second, Larry. And then you had to kind of do this math and figure out, well, how high is that thunderstorm, and are we going to be able to top it or not? I don't have to do any of that. I turn this one on and it scans up and down by itself. I don't have to set it at any particular altitude or degrees up. It scans for convective weather in front of us. It will show us on the screen what's right in front of us and whether we're going to clear it or not. So I don't have to do any more math. I don't have to get any more charts out and look it up. It'll tell us whether we're going to clear it or not, which will somehow take the fun out of it partly, with the two guys in the cockpit going, we're going to clear that. No, you're not. You're going to hit the top. So at any rate, we're going to take some of the fun out. Larry.
If you have one engine out, can you sustain altitude on one engine, and how far can you go on one engine?
Oh, good question. One engine operations with this airplane. There's a program that's referred to as ETOPS, which is extended operations. We pilots refer to it as engines turn or people swim, but it's extended over water. Right now we use what's referred to as 180-minute ETOPS, and I've got a couple of charts down here if you want to take a look at them afterwards. I've got a chart down here in the front of a polar route that we flew the other day going to Shanghai. And I've got another one out front that's a North Pacific route if you want to take a look and see what we do. We right now have to be within 180 minutes of a place to land. That's 3 hours. That's 3 hours single engine. We are in the process, we aren't, but the FAA and the manufacturers are getting ready to work on a 330-minute ETOPS. That means flying single engine for 5 hours. It gives you a lot to think about for 5 hours. Yes, sir.
Compared to metal airplanes, what is about the fatigue life of the composite airplane?
He's asking what the fatigue life is on the airplanes with these. I don't have specific numbers because we didn't talk about that much, but they tell us that that these airplanes have a lifetime 5 times longer than normal airplanes. Yes, sir.
Will it float?
Will it float? If you keep all the doors closed, probably. I don't know. I don't know if it'll float or not. There's no consideration made on the airplane for trapping air in the airplane. It does have a system on it that produces its own nitrogen to fill in the voids in the fuel tanks. And if any of you remember TWA Flight 800. That was the one that was out off of Long Island that blew up, and one of the suggestions or findings was that it may have been due to fuel atomization in the fuel tanks, in the center fuel tank, that somehow exploded. And so now, in this airplane in particular, and this is the first commercial airliner to have a nitrogen generation system that pumps nitrogen into the fuel tanks and maintains that inert gas in there so that you can't have any flammability in there. They're starting to put some of them on the 737s now too. But as far as floating, I don't know. In the Hodgson. You know, everything will float for a while. Anybody else? Yes.
Are they planning final assembly in North Carolina?
The question was, are they planning final assembly in North Carolina? You heard references here to Charleston. And you may have seen some things over the last couple of years about issues between union, non-union workers, and they finally came to an agreement, and so they're now building 787s in Charleston, the whole airplane, to try to do catch-up work. The first one came off the line last week and is going to Air India. So yes, they are producing them in Charleston. The first one came off the line last week. I'm not sure. In fact, I don't know whether you're all aware of this or not, but all of the Charleston airplanes will be coming here to Fort Worth for paint. They're all going to be painted here in Fort Worth. So you're going to see a lot of 787s around here. And let's see, there are, I think, as of a week or so ago, there are, All Nippon Airways has 7 of these airplanes. JAL has 2. And those are the only ones that are presently flying in addition to the Boeing airplane that's flying. We will receive our first airplane in September, and it will be utilized within the company for maintenance procedures and to train some of the check airmen and things like that during the month of October. During the month of November, we will get 2 more airplanes, and they will start to train people like myself, the line pilots, and starting to get us our 100 hours that we're required to have to be off of what's referred to as high minimums. In November, we're supposed to get 2 more, still probably flying domestically on certain routes. They'll just pull airplanes off of routes and send us out on the 787 to get us our time and get our training in. And then probably in December or January at the latest, we'll start flying the airplane international. Right now, they're planning for us to fly the airplanes out of Houston to Auckland, New Zealand. So that's about as far as you can go. In Houston, the question was flight simulators. Houston has, we have a flight simulator. United has a flight simulator in Houston, and Boeing has one. So there are 2, and we have one of those airplanes. Yes, sir.
Any knowledge on the European CO2 tax emissions?
No, really don't know about this one. But the question was any knowledge on the European CO2 tax. As you probably saw in that slide that I had back there, the CO2 in this airplane is 20% less. So really don't know what's going to happen with that.
Are we being taxed right now, the American
I
companies?
have no idea. I have no idea. Yes, sir.
You said that you start both engines at the same time?
Yes.
And I assume
The question was, do we start both engines at the same time? Yes, we do.
And when you do, they're started off ground power?
Yes, ground power or the APU. Yeah, we can start with either one, but it's the longest start I've ever been involved with, other than some things like the F9 years ago. You pull both of the condition levers up on the airplane, and it takes 2 minutes for the engines to come up to speed. So it's really a slow start. Anything else? Yes, ma'am.
So what was the music theme?
Pardon? Oh, the music theme. Anybody know what the music theme was? Anybody? Terminators. So there's no young kids here, so that's probably why. That's good. That's good. Most people don't know what that was. Anybody got anything else? Yes, sir. Transformers. I'm sorry. Transformers. Yeah.
You were showing the movie inside, and you showed the pilot's rest area.
Right. Yes.
Can you accommodate women pilot and men pilots at the same time?
Good. The question was, we showed the crew rest station for the pilots in the front of the airplane, and there were 2 bunks up there. And the question was, can we accommodate the women and the men pilots? It's co-ed. It's co-ed. 1 person to a bunk. 777, it's easier because they're like bunk beds, but this one, yeah. Any other questions? Because I've got one other short film for you, and then I'll let you run away.
Just one.
Yes, sir.
When the A380 came out, they advertised it as the most electrical aircraft ever produced. Can we say the same thing about the 787?
This one is more electric than than Airbus. Airbus the 380 may have been at that point in time, but it isn't any longer. The 780 is way beyond that. In fact, you'll hear a lot of references to the 780 and the 350, the Airbus 350, which still isn't due out for another couple of years. And they were kind of similar in terms of distance and all the rest of that kind of thing. About, 4 years ago, when the airplane was supposed to first come out, the 78 was? 3 years ago when it first flew, at that point in time, when this airplane was 80% lightweight materials, 50% composites, all electric, the 350 was still using 1980s technology. So Airbus is trying to do catch-up with the 350, and so they're going to have a lot of making up to do. But the Airbus, the 380's got a lot of problems right now still. Yes, sir.
Did you request the airplane, or was it offered to you? I mean, I applaud
Me
you.
personally?
Yeah, I applaud you for learning such a complex machine.
This is, to me, this is very special. And the question was, did I request the airplane or was I assigned to it? I think that was essentially it, wasn't it? Yeah. It's all a seniority deal. Had I retired 4 years ago when the age limit was 60, I would not have flown the airplane. The age limit on mandatory retirement was moved to 65, and my seniority increased and other people left. And so I took the first opportunity to fly it because I knew there wasn't going to be a second chance with this airplane. Most pilots will tell you, I'm not going to fly the first airplane, the first model. I'll wait until the B model comes out or the Dash 2 or whatever. So I feel very fortunate that I happen to be in the right place at the right time. It has nothing to do with skill and daring. It has everything to do with date of birth, that I happen to be able to be in the first cadre of pilots. I'm probably the 25th pilot in the United States to be type rated on the airplane. I'm the second most senior at United. I'm the only one here in North Texas right now. So yeah, I feel very, very fortunate that I'm going to have an opportunity to actually fly it and be involved in the program. It's really special to be involved in a program like this because we're launch customers for it here in the United States, and having been in the second class, we really have an opportunity to go through the program that people have been planning for years, and for us to put some feedback back into the program and for them to modify the program a little bit. They said when they saw us in the schoolhouse, they were really glad to see some people they didn't know because they've been teaching each other for years. So, yes, sir.
I know the one thing they didn't address was who designed the wiring, and is it all designed, built by one company?
I don't know about the wiring. The wiring is, a lot of it is fiber optic. It's all fly-by-wire. But fly-by-wire has been around for quite a while now. But I'm not certain who's done the fly-by-wire on this. I know that there was a lot of things that they wanted to do with the fly-by-wire or with the wiring systems on the airplane, because it is fly-by-wire and because so much of it is computer and networking and that kind of thing, and they wanted to ensure that the network was secure and that some 12-year-old kid in the back couldn't hack into it, or somebody worse than that. So the airplane is very secure from that standpoint.
Jim?
I do now, yeah, I absolutely do now. Yeah, I mean, it's just, I did it for 2 weeks, and I've been off and been back to the 777, and I went back in the 777 for this last trip, and I missed things that I only had for 2 weeks on the other airplane. It's going to be real sweet.
You have another film?
Yeah, I've got one more short film.
We'll watch the film, and then we'll let him answer one question. Because this place turns into a pumpkin at 9 o'clock.
Gentlemen, this is your first model. Jet you are flying against are faster and more maneuverable, just like the enemy did. The clock is ticking, and as of now, we are keeping score. Here we go. All right, Dr. Goose.
Okay, Bob said one more question. Sure you can, one time. I can do anything. I can do anything I want one time.
Do you ever think there's too much automation on that thing?
Ike asked whether I thought it was too much automation. For the things that we have the capability of doing, no. It reduces the workload an enormous amount and allows us to manage the flight, especially under emergency situations. In an emergency in this airplane, the captain becomes the manager of the situation. I run the checklist, the co-pilot flies the airplane. Of course, if I've got 4 guys and I've got 2 more up there to help out. But no, I don't think we've gone too far with the automation at all. The backups, I've got more backup systems on this than I had on the 727. So there were a few things. When I went to the 777, I noticed 2 things that were surprising to me, and that they were little light bulbs that went off. And anybody who's flown airplanes for a long time, you remember the cockpit checks that you used to do with the cards, and you did blindfold cockpit checks where you had to sit in the cockpit and you had to memorize where the switches were. And the switches were different shapes, and the dials were different shapes, and things like that, so that when you were in the dark, you could find different systems and operate them. When I got into the 777, and even more so in this one, I noticed 2 things. One was that there were 2 kinds of switches and dials in the airplane. There was a lever latch, and there were buttons. And the buttons were all square. So I wasn't going to find the difference in anything up overhead by feel. And that told me I will never be in the dark in this airplane. It's simple, but I will never be in the dark in this airplane. And it also told me that I was going to be more of a systems manager than a pilot. We can hand fly these things. We can do everything we can in any airplane we've ever been in. But with the automated systems, we can do them far better. And we can take you all across the world, 5 hours single engine if somebody would want to do that. And we can get you to wherever you need to go, regardless of the weather, and we can get you there safely. So, no, I don't think so.
Well, did everyone enjoy this presentation? Well, Jim, we have a little presentation for you, being you are going to be the first pilot in North Texas to fly this bird. We've got a little print here. It's the first flight of the B-36.
Great.
And it is signed by Burl Erickson, the first man to fly the B-36.
That's very nice.
And also he flew the first B-58. Thank you, Jim. It was a great presentation.
Thanks, Buster. Appreciate it.